Today we're looking at nonlinear relationships, which is Chapter 8. By the end of Chapter 8, you should be able to cover the following skills. Initially, we're going to look at 8a, which is looking at the parabola. Parabola is described by a quadratic function, and quadratic functions are a curve whose equation has an x squared. So we've been looking at linear equations which just have x. It is defined by the general rule y equals ax squared plus bx plus c, and has the general curve as seen here, where a, b, and c are numbers. You can also get a combination of those, but as long as you have the x squared, then it is a quadratic function. Key features of the parabola. The basic parabola has the equation y equals x squared as seen here. You have your turning point here, which is 0, 0, and we write those as ordered pairs. We also have a line of symmetry which cuts the graph in half, which is also known as the axis of symmetry, and for this particular graph it is where x equals 0. By putting a negative on the graph, we actually see a reflection of this graph. So if you have y equals x squared, which is our basic quadratic graph, if we have a negative, so y equals negative x squared, we see a reflection of that in the x-axis. Adding or subtracting a constant to the x squared moves our graph up and down. As you can see here, -1 moves it down, +1 moves it up. So the constant actually changes it from up or down and moves the basic graph. The coefficient to the x squared actually either widens or thins out the graph, and it is the opposite of what you would think. The higher number actually makes the graph quite thin compared to a lower coefficient, which makes it quite wide. And again, if we have a negative value to the coefficient, we see a reflection in the x-axis. To be able to draw the graph, you can either use an online graphing tool or your calculator, but you can also do it by hand. And just like we did with linear graphs, what we'll do first is we're going to use a table of values for these values of x, substitute these values into the equation to get our table of values, which looks like this. You're then going to plot those points and join the points on a coordinate plane, and you will get something similar to this. We are now going to find the following features. So the first one is the turning point. And as you can see right here, this is the turning point, which is 2 and 1. The axis of symmetry right down the middle is where x equals 2. The y-intercepts, as you can see here, is 0 and 3. And the x-intercepts are 1 and 3. These are the points that it crosses over the x-axis. The minimum value you will find is -1, and that's at that turning point. This is the lowest point of our graph. Here is another example of drawing a quadratic function. So construct your table of values, put in the values into a coordinate plane, and then join the points. If we looked at this particular graph and we looked at some features, for example, A, the coordinates of the turning point here would be -1 and 4. The y-intercepts, as you can see, are -3 and 1. The x-intercept, the y-intercept is 0 and 3. The axis of symmetry is -1. And the maximum value, because we don't really have a minimum value here, is 4, because that is the highest point of our graph. You can use this particular online tool to graph your quadratic functions, and you can see some examples here and again here. You will need to complete the following questions in exercise 8A.